Hey there, welcome to Concepts of Web Performance. Today we're going to be talking about waterfall charts and why they're important to understand the sequence and loading dependencies of your website. I'm Todd Gardner from Request Metrics. Let's get started. So a waterfall chart. You've definitely seen a waterfall chart before in other web performance tooling or reports. It's a super common way to visualize the sequence or steps that a web page takes to load and how long each of them are taking. But what is it? What does it mean? What do they look like? Well, so you've seen them before in, say, Chrome DevTools. You went over to the performance panel and you ran an audit and you saw something like this. And probably it was so much information and it felt a little overwhelming and you didn't know how to really go any farther with it. Or you've seen it on Web Page Test. If you dive into like the details of one of their reports, you'll see something like this, showing all the assets that make things up. Or even in real user monitoring tools like Request Metrics will show you the assets that go into your web page and how long they take and what might be blocking or getting in the way. But what do these things mean? These are all kind of complicated. So let's take a much simpler example to explain what this is and how it works. So a waterfall chart is made up of lots of different items, and each item means something. Each item is like an interesting chart into itself. The waterfall chart item is plotted on an axis of time. So the horizontal is time progressing. And usually we're dealing in very small increments. Usually we're talking about milliseconds. So a document or an image or a script might finish in 10, 50, 100 milliseconds, kind of depending on the size and performance. So that's what we're talking about here. And then the line is the total amount of time that we spent dealing with a particular item, a particular resource or document. The line represents the entire time that we know that we have this job. But each step of that means something different. And so before it actually starts, we have this queuing and connecting phase where we might not know where to get the thing from yet, or we might not have the available bandwidth to make the request, or we might just be busy doing other things. Then on the left, we'll say, hey, we have this request waiting. We've fired a request to a web server or CDN or whatever to get the document, but we haven't received anything yet. We're waiting. Then on the right, we have content downloading. We've started getting something. We have to process all the bytes that's coming in off the wire. And then finally, we'll have to wait for the main thread of the browser to give us control back to do what we need to do. We might need to modify the document in some way or take control, and we might be waiting on some other resource to give up control in order to do that. And then so each of these things will be laid out on a waterfall chart, and the colors are important in their meaning. So usually we'll see a blue one first. That's the HTML document itself, followed by style sheets in purple and JavaScript in yellow gold, and images are green and fonts are teal color. And then there's inevitably other things like API requests or iframes or other things like that. So let's look at a super simple example to kind of explain that waterfall chart. So here is an HTML document. It's got a couple of things in it. It's got two different style sheets and a JavaScript file in the head. And then in the document itself, we have two different images, just image 1 and image 2. I wasn't particularly creative with how I named this thing. But a waterfall chart for this would look something like this. So first we're making a request to index.html. And we probably are able to request it right away. There might be a little bit of gap where we're waiting for the previous page to unload or something like that. We download the HTML file itself. And then that lets us understand the outer kind of shell of this markup. Now, once we've discovered that markup, we start learning about the resources on the page. The first two being style 1 and style 2. Now, there's nothing blocking at this point. The index is done. There's nothing else for the browser to do. It may as well just start doing its thing. So it fires off requests for style 1 and style 2 that take some amount of time for the browser or for the server to figure out what to give us before streaming the bytes back down to us. That would describe those first two lines. Now, then we have a script file. Now, the script file, we discover it at pretty much the same time. We discover it right at the beginning. However, every browser has a limit on how many things can be requested at once. And that depends on the browser and its device and the network it's running on and lots of other factors. For the case of this example, I'm showing that I can only make 2 requests at a time. And so in this case, I am now waiting. I'm waiting for these other requests to finish before we can fire that out. And then we have some small waiting time while we're waiting for the browser or the server to return data to us. And then we get a huge JavaScript file back that requires lots and lots of bytes. Now, that's not the only thing on the page. Down here in the body, we still have a couple of images to deal with. Now, those are also discovered at pretty much the same time. It's all kind of on that outermost shell of the index.html. And so we learn about those images, but we are constrained in the same way. We can't make an infinite number of requests. And so we are waiting for these other CSS files to finish before we can make those requests. And then we're waiting for this one to finish before making the other one. And then we end up kind of blocked for a little while here at the end because we're waiting for this JavaScript file to finish doing its thing. And that's an important and subtle behavior that we're going to talk about here in a second. Now, waterfall charts will also overlay important events as these little flags. Now, in this case, I've overlaid LCP, which is an important Core Web Vital metric called largest contentful paint. It's a signal that when the largest element, visual element on a web page has rendered, that's when it signals. So presumably this image is the largest contentful paint, is the largest thing on the page. And so once it finished, the LCP was triggered. And then the load event, often shown in red. The load event is triggered once everything on the page is done and completed. It's often treated as the page is done, the spinner has stopped, it is completely ready for the user to go. Now, there's two really important patterns to look for on waterfall charts that indicate significant performance problems. And the first is a sequential chain. A sequential chain like this, where we discover a resource, and then a new resource is discovered immediately following that. And a new resource after that, and a new resources after that. Now, unlike our simple example, all these lines don't start here together. It's not like all of them started right here. We're not even aware of this script file until this one has finished. And we're not even aware of this font until this one has finished, indicating that like each of these things is pointing at the other as a dependency. And it's causing us to wait a long time to pull everything together. Solving this, there's a lot of different ways to do it, but generally we want to flatten this as much as possible. We want the browser to at least know about these resources way back here so it can start downloading them if it has the capacity to do so. And we can do that with like preloading or just flattening our dependency tree. The other thing is what I was alluding to earlier. It's around parser blocking JavaScript. Now, JavaScript itself, when it finishes, it can cause unusual slowdowns and blocking in other parts of a waterfall. And why is that? It's because the JavaScript execution in the browser is parser blocking. When a JavaScript file finishes, it prevents parsing other content, rendering, and main execution because the browser has to stop what it's doing and execute that JavaScript because it could change the content of that document in all kinds of unpredictable ways. And so what's actually happening kind of behind the scenes is that JavaScript file finishes and then it blocks that main thread to evaluate the script and compile the code and execute the function, where that CSS file here is kind of stuck. It's just waiting. It spends a lot of time waiting for that main thread to open up and for it to finish what it's doing. This sort of JavaScript can cause a lot of problems with performance. I have a whole nother video about it called script loading, where we talk all about this and the differences between blocking, async, and defer. You should check that out. I'll put a link somewhere right here about that. If you want to learn more about web performance, metrics, how to dive into it, I have a whole training course out on Front-End Masters called The Fundamentals of Web Performance. You can check that out. Or if you're trying to make your website faster, check out Unified Performance Monitoring from Request Metrics. It combines lab testing, real user monitoring, and Google SEO data all together to give you this comprehensive picture of how your website performs, what's slowing it down for the actual users that visit it. Super cool. All right, this was reading waterfall charts from Concepts of Web Performance. Thanks so much for watching. If I helped you, if I helped expose something to you, why not give me a link and help me keep making more of these? Thanks so much.